Well, hi, good morning. Thank you so much for joining me in my shop here. I'm going to be continuing with this radio, but first, a little bit of a comment here on video making that I've noticed. Many video makers like to have a microphone in view of the camera. I think it increases credibility. So I'm going to join those who believe a microphone needs to be in view, and I'm going to put this microphone there. Fantastic. I can feel my credibility increasing. In fact, if you just look this way, you can even see the arm that's holding it up. Even more credibility. Yeah. If you're watching a video being made and there's no microphone in view, then it's not credible and you shouldn't watch it. Of course, I'm being totally facetious here, and that microphone is not one I'm using in my shop. But let's take a look at some microphones from years gone by. Check it out. Can you see the microphone? The microphone's hidden in the lamp. This is one of the things they did early on. It didn't like the microphone being in view, but it had to be close. So here's another one. Looks like he's singing into a great big pie plate or something like that. Yeah. Wait. The mic is hidden in the standard lamp that's here. In the background there's a lamp. But obviously there's a mic there, but there's also, he's obviously singing into this thing. Okay, some more. Here's a guy. He's using the mic to gain credibility. There it is. He didn't have to have that microphone there. He's probably a broadcaster, and that's why. The first broadcast to lure Canadian listeners away from American programs were Foster Hewitt's Saturday Night Hockey. That's Foster Hewitt. I didn't know that. Here's another one. There's kind of a microphone there. It looks like a soup can. They're sitting around, singing into it. People learning Morse code. Somebody in a church. Here's another view of a microphone. And you see the lamps hanging from the ceiling? Those are probably lamps. And the guy sitting down, it looks like he's talking into a microphone too. Early sound lock studio door. Back here, this is, so no sounds would leak in through the door. They have a double door there. So there we are. So everybody with their microphones. Look at this one. I need one of those. And who's this guy? That's Mackenzie King. That's just a Canadian political figure. I thought it was somebody else. I'll show you who I thought it was. I thought it was... Are you Canadian? If you're Canadian, you should know this name. If you're Canadian and you're into radios, this man should be your hero. Reginald Fessenden. The Canadian inventor of radio telephony, they're saying there. So this guy has a lot of firsts. You might think Marconi has them or other people have them. He's got them. There's Marconi right here. There's Fessenden and his crew. Happy looking bunch. Pretty happy, don't they? Fessenden seated and staff at the Brant Rock operations. And here's Professor Fessenden in his shop doing his thing, wondering what all these weird sounds are in that radio. Just like me, but this one. Anyway, not to go on, I love these old books. I love seeing these old pictures. Look at the apparatus this guy's got. Who is it? Early wireless telegraphy. Note, wires strung everywhere compared to Fessenden's orderliness. Now, Professor Fessenden is also a pioneer in television technology too. But you know what? Us Canadians, we don't know the name. Because he wasn't interested in promotion. Now, should I put this microphone right? Let's get it right in the right spot here. In all honesty, I watched a video of a guy, it's a talk video, and a guy's talking into the camera, and his microphone was literally covering this much of the screen, and a good third of his face was behind the microphone. So, but credibility, I don't know. Okay, let's do some radio stuff here. Okay, so I'm a little curious about one particular capacitor that shows up on the schematic, and that's this one right here. When it's connecting the rectifier cathode to the rectifier plate, where it's between the plate and cathode. It's some kind of filter or something. So to understand its purpose, because sometimes these things have more than one purpose too, I got out one of my favorite books here, and I looked through what I could find in here on this topic, and really nothing. Here's a 5-tube transformerless radio of a similar design to the one that's here, and there is no such capacitor installed, and so there's no comment in this book on such a capacitor. So I was getting a little frustrated trying to figure it out, and suddenly I thought, well, why don't we just ask AI? Let's just see what AI has to say about this. Okay, so I'll show you my question first. Here's my question. I'm working on an AC 5-tube radio without a power transformer. There is a 0.04 microfarad capacitor installed across the rectifier plate and cathode. What is it for? And here's his answer. The 0.04 microfarad capacitor across the rectifier plate and cathode in your AC/DC 5-tube radio is likely there to reduce noise and filter out high-frequency interference. This type of capacitor, often referred to as a bypass or filter capacitor, helps to smooth out the rectified DC voltage by bypassing any AC components or ripple that might be present. Well, maybe not a 0.04. Okay, that'd be like a 20 microfarad doing that. This ensures a more stable DC supply for the rest of the radio circuitry, which can improve overall performance and reduce hum or noise in the output, in the audio output. Is there anything else specific about your radio project I can help with? Yeah, probably, but not right at the moment. Okay, so that's what Mr. Bing had to say about it. That was Microsoft's AI system called Copilot. Well, I'd say let's replace that capacitor. I don't think it's going to have any effect, but let's find out. Maybe I'm wrong. After all, I don't have a gigantic microphone sitting here, so my credibility is low right now. Okay. Where is that? Where is that? That capacitor is number 44. Number 44 is right here. It's right here. It's right here. This is 44 here. Okay, let's do it and see what impact it has. Okay, new capacitor's in. Here's the old one. Not in very good shape. The end of it, is popping out a little bit. Like it's almost like a plug coming out. So what exactly that indicates about a capacitor, I don't know, but that's a common thing that I find. Why the end is pushed out like that, I don't know. Maybe it's just falling out. But surely if this separates too much, then there's a loss of contact between the wire and the foil. It would take quite a bit, though, to do that. But some of these do lose contact internally. So let's put them on the tester and give them a try. Okay. So I guess this one had the entire B plus across it, and unfiltered B plus. Is that what was across it? I'm not sure. You could say that about it. Okay, here we go. What do you do with 50 volts? My gosh, it's coming open. 150 volts. I don't think it's going to open with that. So all these capacitors are in a similar state. This one's actually a little better than some of the others, according to this test. You have to think about what its job was. And what capacity remains in here. I suppose most of it is still there. Okay, so we've got the new one in. Try the radio out. I have to set up the SDR if we're going to try to look for the weirdness, which is probably still in there. Okay, well, let's do that. Okay, so you're looking up at the SDR display and you see a bunch of things showing up. That's through the broadcast band. And if you look at my SDR here, there is no antenna connection to it at all. That's what's coming out of it. So yeah, maybe I need a new SDR. This is one of the cheapest, earliest ones that came out. There, see, I put the antenna on. It didn't even make a difference. What if I touch this? Barely makes a difference. Okay, it's definitely working though. Now, what I want to do is turn on the radio. I think I'm going to full screen the SDR for this. We'll turn on the radio, we'll watch what more shows up on the SDR, and then we'll look and see if it's still full of crazy stuff. Okay, let me full screen this guy. Okay. Now you can't see what I'm doing. I'm just going to get the power switch. The next click you hear is the power switch coming on, and the volume is up a bit so you'll hear the radio once it starts up. Here we go. What will happen? I think the first thing I saw was a local oscillator last time. I'm tuned to the low end of the band, so here it comes, right up around 1,000,000. And we have hash on top of the hash. And then I'm turning down the radio because it's pretty loud. We'll tune it. Oh, well, it didn't make any difference at all. Let's go to the shortwave band. And I do not have I just have the antenna lead wire hooked up, not the ground right now. There's that weird thing, I don't know what that is. So we see nothing on this display, but we're way low frequency wise on that. So I'm going to take this up. Way up now. Tuning around. Let me tune slower. So all this stuff is still in there. Now the radio can only hear two things. A signal at the tuned frequency. Well, I'm in the middle of the band here, so it's somewhere around, I don't know, 11 or 12 megahertz here. So if I were to supply a frequency to the radio that matches its tuning, we would hear it. And the other one is anything at 455. Am I making sense? I'm losing my mind here. Losing my mind again. So I wonder what these buzzes are. I need to investigate that a little bit. Tuning way up to the other end where I think there's a much louder buzz. Hey, what happened to all the weirdness? So I'm tuning up and that thing you see is going down. That's a bit of weirdness. Less and less weirdness as I go up.
Forgiveness. You charge them to depart from sin.
Depart from sin. Okay, going down, 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 down. The farther down I go, the more weird stuff there is. Right down to the bottom, at the bottom now. Yeah, I cannot account for those things in any kind of detailed way. Okay, so radio's operating quite well though. Despite, once again, my continuing attempts to do something to it. I guess at this point I've got to pick another yeah, what is that? Let's find out what that is. How can I do that? First we got to know what frequency this is tuned to. So we'll leave it like this. Take it off the antenna. It's definitely coming in on the antenna. You know, I'm not going to pursue this because I think it's going to be too wide-ranging during this video for me to start doing this. So I won't. Instead, we will pick another capacitor to try to clean this guy up. Let me just turn the power off before I forget. Look now. Maybe we go by size. This is the big one here. I believe that's the 0.1. That is, let's see. I don't have to believe anything. I can find it out. It's this guy right here, which is number 10. Number 10, I believe it's a bypass. Yeah, right here. It's the bypass on this cathode resistor. I doubt very much this would have any impact, but what do I know? Okay, let's do it. So power's off. I'm going to cut it out and test it, and then I'll solder in the new one. Give me a clip lead. Looks very sealed up. I don't think this is wax on the end here. This is some kind of plastic material. This one's cracked here. No, I think it's just an overload. It's just the way it was put on or whatever. This doesn't really feel like wax. This is some kind of plastic coated capacitor. They really pour on the plastic on the ends. Put a little on the surface. Okay. Don't know. I don't know. Let's do another. Okay. 50. Okay, 50 volts on the big guy. What does he do? He opens up nice. 150 volts. Can't do it. So again, it's similar to all the others. Hard to say if this is better or worse. It's in a bypass position. I believe a little bit of leak there would mean nothing. So this capacitor was probably doing the job just fine. But he's out here now, so he's done. And this was a 0.1. 0.1. Okay, got to hunt down a 0.1, but the thing is, it can be low voltage in this position. Great, 0.1. Okay, ready to try again. Here we go. Let's just check this. Yep. Okay. Away we go. So what are we going to see here? Okay, there's some stuff coming in. You can see it on the waterfall display. It doesn't look, well, I'm not on the broadcast band. Let's tune around here a little bit. What was that stuff? Still weird things going on. Okay, so we're going to flip down to the broadcast band. I'm going to continue looking on the SDR way up high there. This is the broadcast band you're hearing. And it doesn't seem like much happens up at 11 megahertz when I'm tuning around down here. So let's go down there. Could end up making a lot of observations that really just cannot be accounted for, or I cannot account for them. But that's okay. You just put them on the shelf and wait till another radio comes along. Okay, so now we're on the broadcast band. I'm going to tune, and it's just full of nonsense. It's just full of nonsense. The key thing is, what about down at the IF frequency, which is down here? And you can see the nonsense just carries on, sweeps right through there. So could it be some of the buzzing we're hearing is coming into the radio right at that frequency? Otherwise, I think all we can really hear here is where the radio's tuned, 1567. No, that's where the SDR is tuned. This radio's not tuned there, this radio.
May? Not bad. What are you watching at 4 o'clock? You really want to see play Dallas with their backup band?
And you know, when you look at the SDR,
The Detroit-Houston game.
especially look at these two here.
Detroit-Houston should have
Well,
been
tune the radio a little bit, you'll see those two things, they don't go anywhere. They're just sitting there.
Feels right now.
What are they?
Detroit is going to pound them into dust. I've looked at that. I think the line right
Okay,
now
I'm going to kill the power and we'll see if those things disappear. No. Something inherent in my SDR. I have another SDR, another cheapo. I could swap it out and see what happens. Find out. You know, maybe at some point, maybe I'm going to have to try that. For now, we got a couple more capacitors to do. Not terribly hopeful here. Very good. Okay, break time. Okay, so the capacitor we're interested in this time is this guy right here, C37, 0.02 microfarads, and it's right across the plate to almost directly onto the cathode. It's below this cathode resistor, basically tied back to the B minus line. So it's basically robbing something out of this circuit and dumping it to ground. Look at a little section in the book here I'm going to read to you about this capacitor. So let's take a look at that. Okay, let's have a look at this. So this is from the Elements of Radio Servicing book. There's a couple versions of this book. So this is kind of just a typical output circuit. You've got the audio coming in here, speaker over there. There's the capacitor right there, going from the plate. In this case, they're just showing it go to ground, but basically that's down here below the cathode resistor. It's exactly the same. So let's read what it says about it. They call it an output condenser or output capacitor, C12. Of course, it's not C12 in my radio, but that doesn't matter. So we'll just read this little paragraph here. Condenser C12 across the signal output circuit bypasses high audio frequencies to ground. The pentode and beam power tubes introduce a considerable amount of harmonics, which will be most noticeable in the high audio frequency range. Placing C12 across the signal output circuit bypasses some of the signal away from the output transformer. This effect will be greatest at the high audio frequency, since the impedance of a condenser decreases as frequency increases. It's basically like a tone control, if you like. Therefore, the harmonic content will be reduced by the action of this condenser. The average value for this condenser is 0.005. In individual receivers, this value may vary from smaller, 0.001, to larger, 0.02. It's a 0.02 in this radio. Receivers using the higher capacity values have been designed to favor the base register, since the higher capacity bypasses more of the high frequencies out of the output transformer and speaker, making the response deeper by comparison. So that would be why they chose a larger capacitor here. Send a little more bass to the speaker. It doesn't send more bass, it sends less treble, and then the operator will turn the volume up spontaneously, and that's where the more bass comes from somebody turning up the volume a bit. Okay, well, let's go at it. We know what it is, and it has nothing to do with these influences, I'm sure, but it's got to go, and it's really tucked in here. I'm going to nip it here. And then, oh, for crying out loud. Don't look there, look up here. I can be distracted at any moment and come back here half an hour later and I can't remember at all what I was doing, let alone where this capacitor came from. So here we go. So 0.02, yeah. Let's put them on the tester, which I've left on all morning here. Okie doke. Okay. What do you do? 50 volts. So again, it's 150. It's not going to open. So they're all very similar condition, which is quite common in these radios. All leaking a little bit. None of them are like new, that's for sure. This one, if it's leaking a bit, would it cause a problem? I don't think so. Does it have anything to do with the weirdness? No, I don't think so. So we'll put a new one in, and I guess it might quell the trouble a little bit more and cause a higher volume setting, and therefore boost the bass a little bit over the way it was, assuming the capacitance has drained away, which I don't think it can. Okay, here we go. Let's try this. Now I'm sure this won't have had any particular benefit in terms of the weird signals. Let's see though. So I'm on the broadcast band this time. Let's see what happens. Here they come. The forest of them. Look at them all. And if I tune, they're all going around different places.
I try to stay cool.
Now,
Let's talk some odd basketball. I don't know.
I doubt we're going to hear any difference in the sound.
She didn't show up. There were times in bargaining she did it virtually from Florida. And I think if you want a job like that, just like this job, or you want to be chief of police or these important jobs, you need to show up every day and work hard and do your best. Unfortunately, she didn't do that, and it's resulted in us getting to this situation now.
Lisa's numbers discussed in negotiations were publicly released, but Campbell says that was all done.
So that's Canadian news, by the way. If you're trying to figure out how that applies to what happened in the States recently, then no. Okay. Well, we got more capacitors to do, and I'm running out of time here today. I think I'm going to leave the rest for tomorrow. What do we got left here? There's one hidden way up and behind this coil. Look at as I tip this, I'm bending this part of the chassis, and I'm moving this coil. That's not good. Okay, not to worry about it. So we have this guy, we have this big guy, which I'm not sure what to do with him yet, and we have the one hidden way under in here to do. Maybe in the end it's going to be this one. It would be pretty easy to duplicate this since the coil is right on the outside. Whoops. It would be pretty easy, sorry about that, pretty easy to redo this guy. Because the coil is right on the outside, you can see it. So I just remake that on a big honking capacitor. But is that in any way related to this situation? Perhaps when we get to it, we can test it somehow in its position and make some determination, because big capacitors, I don't have many like that. Okay, that's it for today. Thanks a lot for watching, and I'm guessing in the end we'll have everything done, and that stuff will still be running around inside this radio, and that's just the way it is. I don't know. Okay, have a great day. We'll see you on the next video.